When you want to calculate height of structures or planes, we provide a set of tools in MountainsSPIP. So let's pull this first data. You have one step. You have a top layer and a bottom layer, and you might want to measure the height difference between this one and this one. To do so, you will find the step height studies in the Studies tab. And this is the step height study. You can calculate the height difference manually. You will first draw a shape, like a rectangular shape, around here for the first plane. You will draw another rectangular shape for the second plane. The software will calculate what's the average of the height in the plane 1 and the plane number 2 and gives you the height difference. Again, we display a number of information. If you want to display more or less, you double click. If you only want to have the height difference, you do it like that and you click on OK. So you can do it manually, or you can do it automatically, like that. You can see how the detection is being done by clicking on the settings for plane detection. And the plane detection is based on height distribution, of course. And you have this peak detection threshold that you may want to fine-tune. But any peak that crosses that detection threshold will be recognized as a plane. And you have a first plane and the second plane because you have two peaks. You click on OK, and here is the result. Something that could be interesting here is if you're zooming on the data, you see these spikes, and you may want to smooth or to remove those spikes and to see if there is any consequence on that measurement. Maybe they are messing with the calculation. To do so, you can insert in the workflow an operator that will have, as a consequence, it will change these results. And to do so, you right-click here, and you insert an operator after. For instance, the spatial filter. Because these are mostly spikes, not streaks, you might use a different filter size, 3x3, like that. Or you may want to increase it a little bit more if you have remaining artifact you want to remove, like that. You click on OK, and here is the new result. You can deactivate that operator and see the value change. And you can also go back and forth and do redo to see if there is a huge impact on that particular step. If I use another data here, we will see that the same study can be used to detect and calculate height difference when there is multiple planes involved. You go Studies, select Step Height, and you see here the software detecting automatically 7 planes. Again, you can fine-tune the detection by changing the localization of this detection threshold, like that. You select OK, and the results are being updated. Step height analysis is also available on profiles. So we can extract a profile here, change its location, like that. Then you will find the step height in the studies again. Okay. As with the 3D, you could make manual measurement, for instance, by moving this cursor. That's the top, and that's the bottom. And then you will have the mean height and the width. You also have other parameters that can be calculated. But you could, especially when you have multiple steps, it could be interesting to pick the automatic method. And you may need to fine-tune those settings here. For instance, picking automatic detect step width, like that. Or you may want to exclude part of the step here to avoid those sides by clicking on these settings, 10% for instance, or maybe less, 15%. You may want to display the average value or to display individual values like that. And if you change the location of that profile extraction, this will be updated.